Our speaker today is Sjoerd.
Did he say that right? He's been practicing.
Almost.
So he holds the position of survey director in Boskalis, a larger multinational marine contractor company. In this role, he leads the in-house survey department and is responsible for all survey support activities to Boskalis projects worldwide. Sjoerd studied hydrography at Amsterdam Nautical College and IHO Cat A hydrographic program, and graduated in 1986. And he started his career with Boskalis in 1989 as an international field surveyor. Was responsible for surveying the Netherlands home market from 19 to 2000 and became involved in survey management since then. All yours, please.
So he introduced me, so you know who I am. I have a rough idea of who you are. Please feel free, there's going to be a lot of pictures. If you want to know something about what's in the pictures, please interrupt me. And then we will go through the schedule as it is, but there's lots of stories to tell, and if it's a bit interactive, it's more fun, and you will get more out of it. This is a mandatory start for us. Safety for us as a marine contractor is everything. So we have a safety program which is basically not fully regulation driven, but it's about values and it's about rules. And the rules aren't things like wear a hard hat. It's about what are your values, and I'm responsible for my own safety and for others' safety. And the rules are prepare a risk assessment. Use your brain. Basically, that's part of the most important thing of our safety statement and program. Won't go into too deep. What we'll do, the first part is basically a copy of the Boskalis corporate presentation. So it'll introduce you to what we do, where we do, why we do it. Something about the strategy, which is based on sustainable growth, and it also mixes in with what is very important at the moment, things like CO2 emissions, that sort of thing. You'll see a lot of pictures in that part, so if you see a picture you want to know something about that activity, then we can stop, talk about the activity and continue. And lastly, I will illustrate why surveying is totally important in everything we do. So let's get going. So what do we do? Company overview. Leading global dredging and marine expert. We were founded in 1910, so we have been around for over 100 years. 11,000 employees, 500 vessels. Anybody knows how many vessels there are in the US Navy? Less than 500, so our fleet's bigger. It's important to know. At some point we had over 1,000 vessels, and then I could say it's roughly 3 times the US Navy. We're active in 90 countries around the world, so we work everywhere, which makes us truly international. We have customers in energy, in ports and infrastructure, and our headquarters is in Papendrecht, which is a very small town in the Netherlands. We have 3 business segments. As you can see, dredging and inland infra. This is where our roots are. Up until 15 years ago, that's all we did. So we reclaim land, we dredge access channels, we build ports, we do coastal protection. That's our core of what we do and where we came from. Unfortunately, we can't do that here because the Jones Act prohibits us. But we do it in the rest of the world, including China, including, well, name any place. Then another key market of ours is offshore energy, and you'll see lots of examples of that. The third thing is towage and salvage, and these are our 3 divisions as well. Boskalis got 3 divisions. One basically moving earth, one providing services to the installation services to the offshore energy part, and doing towage and salvage. Smith Salvage is a 100% owned daughter company of ours, and they're in the same building. So this is roughly where we are, well, almost everywhere. We do have offices in the US because currently we are installing 2 wind farms offshore Rhode Island. And we do have that because of the heavy lift vessels. 2023 results give you an idea of the size. Revenue, about 4.3 billion. EBITDA, about $1 billion. Net profit.
Dollars or euros?
Those are euros, so multiply by 1.1 and you get dollars. And net profit of about 600 million euros, so 660 US dollars million. Net financial cash position, this is interesting, 500 million, so roughly almost 600 million net cash position. That's if you want to take over somebody, you have the money. So this is the mission, the purpose, why we exist, and our values. And the mission is to be leading dredging and marine contracting experts, we think we are, creating new horizons for all our stakeholders. I haven't thought of this, but it sounds pretty good. The purpose is, and that's actually more important, we create and protect prosperity and advance the energy transition, with emphasis on transition. And our values are, well, what I just touched, the safety program. We're a team player, we work together with other companies. We're entrepreneurial, we want to be professional, and we want to be responsible. Strengthening to our contribution to the United Nations Sustainability Development Goals. Obviously, clean, affordable energy is where we are very much involved. Climate action through coastal measurements, preventing flooding. Industry innovation, we'll touch on that later. Decent work and economic growth. We care for our staff, we care for the local societies that we touch when we are there, because we do touch them. And life below water, obviously we do everything in the marine environment. Energy clients, offshore oil and gas and wind, both we do. Ports, obviously, governments, port and terminal operators, shipping companies, insurance companies. That's mainly, again, salvage actions there, and infrastructure for international project developers. So this is the organization. Group management on top, board of 6. Then corporate support, legal, IT, HR is there. Central business. That's where our central fleet support department also is, that maintains and does things with our vessels, but also my department is there. So I'm not part of the divisions that you see below. We're a central service, and we provide services only within the company. So we're not a commercial survey business. We do have commercial survey businesses. They're in the offshore energy department, but they're completely separate from what I do. I support Boskalis projects. And these are some pictures of what we do. These are our activities. You can see there we do a beach replenishment, which is something we do a lot. Bringing sand back on the beaches to make sure that erosion gets stopped and doesn't proceed. We build terminals. We transport FPSOs around the world on a vessel. So that's a complete FPSO on a semi-submersible vessel.
What's an FPSO?
Floating production and storage unit that is used in the oil industry. So they'll get oil out of the seafloor, pump it into one of these vessels, which is basically a processing plant, and then a tanker comes along and brings the processed oil to wherever it needs to go. And if they get old, then you can't tow them anymore because they tend to fall apart. That's the heaviest, the largest semi-submersible vessel in the world. We can fit a whole FPSO on it. There was a cruise company, I don't know which one, that had a problem docking one of their vessels. They had damage. They asked us, could you sail in, go down, make a dock where the vessel was. We did. Inland infrastructure, we do. Here in the lower part, so you see a small little upper barge with a crane on it. They're putting sand against a dike. This is actually in the Netherlands, to reinforce the dike. We build roads, we do dive support and construction support services. We have 2 of those large crane vessels that will install offshore wind farms. And don't be fooled by the size of the picture. The vessel is 250 meters long. It lifts 5,000 tons. The monopile is 10 meters in diameter. That's huge. In total, if you were to, I haven't got a picture of that, but if you see the whole construction, so with the windmill and the turbine on it, it's the same size as the Eiffel Tower in Paris. They're big. We install those. We do towage, emergency towage. We have some of the largest pollard pull tugs in the world, and we do, very interestingly, rock dumping with fall pipe vessels, where we protect existing. If you install a pipeline on the sea bottom, then that needs to be protected, weighted down, and protected for people who drag anchors and that sort of thing. So we put rock cover on those. Let's go a bit into the dredging action. 3 of our vessels here. It is a global capital intense business with a high barrier of entry, because a dredger vessel, a modern one, costs about $200 million, slightly under 200 million euros. So if any of you thought, well, I'd like to be in dredging, let me start a dredging company, you're going to have to build one of those vessels. That's a high threshold. We construct maritime infrastructure, ports and waterways, climate adaptive solutions. There's pictures later of things we do in the Maldives. Land reclamation. Obviously, there is a shortage of land near the coastline. So one of the projects we're currently doing is building a new airport in sea in Manila. We have, I think, added something like 20% to the total territory of Singapore over the years, expand the land into the sea. We've done a lot of reclamation in the Gulf, in the Emirates. And we do inland infra, but that is mainly in the Netherlands. But we have the ability, and occasionally we use that if we develop a port somewhere, and the people want a road to that port, we have the capability to also include the road in our bid. I haven't done any railroads yet. Track record of selected projects: Manila International Airports, Gully-Falu in picture below in the Maldives, where we are actually reclaiming land and heightening it, because sea level rise is a very bad idea if you live in the Maldives, where roughly the land is about 50 centimeters to 2 meters above the waterline. They are really worried. We're building currently the Fehmarn Belt Tunnel, which is a connection between Denmark and Germany, and that tunnel is an immersed tunnel, and it'll be 18 kilometers long. We're providing all the dredging works there to submerge that tunnel in a ditch. It's an interesting positioning challenge, because tolerance between 2 elements closing on each other is 25 millimeters at 40 meters of water depth. It's a bit challenging. Singapore extensions to us to come. We were the lead contractor when Egypt decided that the Suez Canal needed to be a 2-lane instead of 1-lane connection. We did that, but we had to do that in 1 year. It was a challenge. And some other things, various other projects. I won't go into too much detail. Here you see some pictures of the dikes we're reinforcing. That's work in the Philippines. Large reclamation project in Singapore. That's what you see here. This is interesting. This is where the tunnel is going to go. And these here are concrete factories that will build tunnel elements. They're building the elements and they get towed out, submerged, connected to each other. And that way it's an 18 kilometer long connection.
I always had a question about this. You build a tunnel like this, are those segments placed on top of the seafloor or are they buried beneath the seafloor?
You dig a trench, you put them in, then you put a layer of rock in, so that you have a solid foundation at a certain height, of course. Then you lower them in the trench, then you fill up the sides, and then you put some cover on.
So the overall seabed height stays close to what it was originally?
Yeah, that's the idea. Usually you build that through a shipping lane or something, and you don't want to reduce the navigable depth. So usually the end rock that is on there is even lower than the surrounding seabed. So it's a pretty deep trench you have to make. And that's a challenge because here you are, usually the current is going perpendicular on your trench trajectory. So you're making a trench and you don't want fluid mud in there because you need to put rock on the undisturbed soil to have a sturdy foundation. And in the meantime, all the sediment is being brought in. So sometimes if it takes too long, that's why you can produce these elements quickly, because if it takes too long, you'll get sediment buildup. And then if you try to lower the element on the bed, there will be mud in between, and then it'll keep moving. It's a challenging business.
How often do you map that area during the construction time?
Once, twice daily.
Once daily.
That's we'll come to that, but it's like doing a survey of 3 weeks, just data acquisition, then coming back to an office, processing that, and having results 6 months later is not exactly our cycle time. We typically on these dredging works, it's survey in the morning, process in the afternoon, get the data on board the vessel by dinner time. Because otherwise they don't know what they're doing. So we have very short cycle times. Continuously. So you actually see, if you're out there as a surveyor, you see the progress and you see the spots they missed. And you want to communicate that to the guys working on the vessel, so that they can, before they move to a different area, that they can take care of the parts that haven't finished. It's a very quick revolving process. And there's a lot of interaction between the surveyors and the crew on the vessels. Because it's not just like, oh, we'll map it and we'll send you a map. You go figure it out. That's not the way it works.
How does it usually work? The surveyor create a XYZ and send the coordinators, like the dredging, hey, those areas you need to working.
The surveyor doesn't send an XYZ, he grids the data in a certain format in the survey office ashore.
Okay.
And since the administrative software for that in the office and on the vessel comes from the same department, which is an in-house department with us, it can read that file system. So you can email them an update and they get the data in and they get a pop-up on their screen says there's new data available. And then they will load the data and then you can have a chat if there's something they need to know or need to understand or have questions. And that's typically how it goes. We never, ever, ever send XYZ data because it's totally against company policy to send them data. If they could load XYZ data, they could get data from another source than our in-house survey department. Then we don't know the value of that data. And since they always work outside of the shipping lanes, because we are creating shipping lanes, we want to make sure that there's no navigation hazards for the dredgers that are not mentioned on their screen. So we don't trust data from third parties to go onto the vessels without it being looked at by one of our own surveyors. They trust us blindly. If we say, and I've been there myself, the dumping ground is there. You have an entrance between two coral reefs, and you have 60 centimeters either side of the vessel. They'll trust us and they'll go. So you'd better make damn sure that 60 centimeters is actually there, because otherwise you'll wreck the vessel on a coral reef. So there is an immense amount of trust, and you can't betray that. Because they want to make production, so they have to go there. They have to trust their colleagues, which is us. Offshore energy. Here you can see a little bit better. That's the Boskalis too. That's a large vessel. There is a slide on how we make that. That's interesting. Markets and activities. Key markets, renewables and oil and gas. All these assets we have, it's a mix of contracting and services, and it is market agnostic. So we can use those assets, those vessels, both for oil and gas and for renewable energy. That's why it's always, we talk about an energy transition. You cannot, it's a process that's going to take, some people think it'll be finished in 2050. Others think that's going to be very challenging to make. So there is a transition. So in between, you will still have to maintain oil and gas facilities. Oil and gas facilities will need to be built. But at the same time, you want to be able to install renewable energy. So our assets are geared to being workable, economically workable in both segments. And we're pretty successful in that. So we do a number of things. We do transport services, heavy lift, as you saw, the monopiles. Marine survey is what we call marine survey, geophysical, geotechnical. Two of our subsidiaries do that. Horizon and Guardline are part of our group. We install cables, subsea cables, so export cables to get power from an offshore wind farm to the shore, but also infield cables connecting the individual monopiles to a substation where it's combined and transported and then exported to shore. We do subsea services, IRM, install, repair, maintain, surf, dive support, a lot of it. 5 large dive support vessels with diving crew on them. And we do seabed intervention, and seabed intervention is preparation, landfalls, and these activities I talked about, installing rock. Seabed preparation is very interesting. If you put one of these power substations in an offshore wind farm, this is like a huge thing, and there's a picture somewhere, I think at the end. It's basically the same as with that tunnel element. You need to prepare the seabed, flatten it out, dump some rock on it to make sure that it can carry the weight, and then you have to install that substation on it. That's part of our seabed intervention activity. We've been involved in over 130 wind farms. There's no other company in the world that can claim that. We're pretty proud of that. Lots of examples. Other things we did, Asta Hanstein, topside float over. I don't think there's a picture there. And when you first set up piles and then you float over a complete production platform, this is something we do. There's pictures of that. Sure. We install FPSOs, do the anchoring pattern, they call it the jewelry. Install that, but also if an FPSO is end of life, we will remove it. Also an activity we do. And we do services, so that's all contracting. Services is subsea IRM maintenance, offshore service support to Jere, Saipem, Seaway Heavy Lift, you name it. That is the support vessels. Here's some projects. Electrification of a gas platform, that's a production platform that used to get its power from burning fossil fuel. The Dutch government didn't want that anymore, so we ran a cable from the shore to the platform so that they can make the platform electric power operated, so that they don't emit CO2 anymore. Although they still produce gas. Their own emissions has gone to zero. Moray West in Scotland, we did a wind farm. That's the Boskalis 2 again. There you see, that's the same big vessel that was in that earlier picture. Now it's got a huge FPSO on it, which is built most likely, I don't know where this one was built, China, Singapore, or Korea. That's where they come from. Then they have to be transported to a gas field, and that's what we do. We have that ship for that. And we do subsea services. Park your boat against an existing platform installation. Send the divers down to do maintenance, to clean the legs, to check for damages. That sort of thing. Salvage, very important. Very high PR value, because these things tend to be in the news. Some survey involvement, not much. This is the Safer. This is an FPSO that lies, well, it's gone now, but that used to lie in front of Yemen, where there's a conflict. No maintenance could be carried out, and it was about to break. And it's 30% filled with crude oil. If this would break, the Red Sea would be completely contaminated. So we were approached by the UN. The UN bought the Nautica, a broker to deal with the rebels there, that we would come in, we would pump the oil from the Sapphire into the Nautica, which is a new vessel. And once that's done, we could remove the Sapphire and avert a true environmental disaster. That's our little endeavor there on the side. Terminal service is part of those activities. Salvage. And salvage is two parts. There's emergency response and there's wreck removal. And emergency response is very different. You don't have a contract for emergency response. You get a Lloyd's Open form because there is an emergency and somebody needs to go do it. So it's called a Lloyd's Open form, and the insurance company, the insurer of whatever is happening and is a casualty, calls us and says, you go fix. We will cover the cost. If it's not an emergency, if it's a wreck that's been laying somewhere, then of course there is a contract. Can you remove that wreck for X amount of money? And it has to be as cheap as possible. So two very different sort of activities. Survey is not very involved in the emergency response, although sometimes we are, but that's all pretty crude work. But in wreck removals, we are very much. Currently, we're removing a jack-up rig that capsized in Borneo. Big job, 2 years worth of work. These are some salvage selected projects, and some things you may, well, actually recognized. We removed the oil from the Costa Concordia when it ran aground in Italy. We opened up the Suez Canal when the Ever Given blocked it. We raised the Kursk. It's in here. I think they very lightly kept it out. The Kursk was a Soviet nuclear submarine that ended on the seafloor, and we sawed off the bow section and raised the rest. We were not allowed to touch the bow section because that had stuff in there that they didn't want brought to the surface. But we all sorts of things. The Fremantle Highway car carrier carrying electric cars that caught fire. the Naga 7 is what I just talked about, it's the rig in Borneo. So that's what we do. React quickly, bring in the expertise that is needed. That's a Fremantle highway there. That's the ever given. It's the Sheffer. Lots of PR value. So what drives this whole business? And this is interesting to know. Population growth and increasing wealth are two givens. That's happening. There's no way to stop it and nobody can influence it. What happens then? That leads to coastal urbanization. People want to live no more than, 80% of the people live within 50 miles of the shoreline. There's growing world trade because people need stuff. They need food, they need water, they need refrigerators, they need air conditioning. They need Starlink internet. That has to be shipped there. People order shit from AliExpress because if you order electric Christmas candles from AliExpress, and a Christmas candle with 3 batteries in it is cheaper if it's brought to your door, and then you go to a local store and buy the 3 batteries separately. So there is an immense amount of stuff being shipped around the world, and we create ports. Energy demand is rising. No matter what people say, there's only a few places in the world where you can live without energy. Probably where we are now. If you did not have energy, you could not live here. You'd simply freeze. So where people live, they need energy. If they want to increase their wealth, they need more energy because they'll get a fridge and a microwave. There's the energy transition because everybody by now realizes that fossil fuel may not be the best thing ever since sliced bread. And on top of that, it polluted the world. So the energy transition is here. People are becoming increasingly aware, not everywhere yet, but in general. So we're trying to transform from fossil fuels to renewable fuels, mainly electricity, and we're in that business. Climate change is happening. Not very fast yet, but the sea levels are rising. The sea levels have been rising for years, but they're rising quicker now. That also is a business driver for us because we protect through climate adaptation. We build dikes. We advance the energy transition by installing wind farms, by installing cables, by making it possible for people to switch from fossil fuel to electricity. And we still create innovative infrastructure. So that leads to a sustainable growth strategy where we have 3 things. Human excellence, because in the end, it's people who do it. It's not the assets you have to have the people to use those assets. The assets is one, human excellence is the third, and good stewardship is important. And together we call that sustainable growth. So that's what we do. We engage with the local communities. We contribute to economic growth by creating infrastructure. If the government wants to increase the wealth of the economy, the best thing they can invest in is infrastructure, because that allows people to become active, entrepreneurial, and start doing things. And we're in that. There's some examples here. I said 130 wind farms we were active in. This is a nice picture. This is a view from the top of the crane on that installation vessel. And what you see here is a hinge. It's called the upending flange. You have this huge monopile, 10 meters in diameter, and it's transported horizontally. So the crane picks it up from the deck and puts it in the upending hinge. And then the upending hinge, then you hold it by 2 points, then you release 1 point and you start upending it. And it shouldn't fall down. So this whole contraption is there to support this enormous pipe to go straight. And the next step is that the crane lifts it out of here and puts it in there. And that thing is called a motion compensated pile gripper frame. Because this vessel doesn't use anchors, it's on TP. And that pile sits in the gripper frame. The gripper frame holds the pile, and then it is fully motion compensated. So it stabilizes the monopile, 3,000 tons, holds it steady, and then slowly the crane will lower it onto the seafloor, because that's the critical point, is when the monopile hits the seabed. If it's on an angle then, it'll keep going on that angle, so you won't get it straight. That's a piece of kit, and that requires some energy in moving that out in the open ocean while the vessel is on DP, holding this steady within 5 to 10 centimeters. So that requires some survey support. Yeah, what else do we do? Here you see one of those rock dumping vessels after installation doing scour protection around the monopile. Because if you were to just put it in the sand and come back 2 years later, you have this huge hole. So that needs to be protected. We provide the protection. It's the sort of thing we do in the energy transition.
So is the monopole pile drive in or its own weight? What?
No, it's the first 6 meters go down on its own weight, but that's nowhere near enough. Then a huge hydro hammer goes on. It is hammered in.
And that hydro hammer is put on by the crane?
Yeah, it is. Maybe you can see it. No, you can't. It's probably out. Oh yeah, here it is. This thing.
Mhm.
This is a hydro hammer. That's being put on top, and then it bangs in the monopile. And then from this frame, sort of a shower curtain goes down all the way, and we make a bubble screen so that we prevent as much as we can the noise of going out. The only thing we cannot prevent is the noise that goes through the bottom. Any noise directly through the water, we try to prevent.
And how deep do they normally go?
30, 40, 50 meters deep. They have to last for 30 years while the gale forces are pushing on the very end of it.
So as turbines are getting bigger, are you able to use the same heavy lift vessels, or do you have to get new vessels or build?
A current monopile is about 3,000 tons. The crane can lift 5,000, so we have some room for growth, but it's limited. But the end is you can also replace the crane and put on a new crane that can handle 10,000 tons. But then again, everything grows in sheer scale. So also the space you need to store the monopile grows in space. This vessel can handle up to 12 meters. That's what it's designed for. So we have another 2 meters to go. We're talking to people like Ørsted who are developing these fields. And they would like to have the Boskalis 3. The Boskalis 3 should be able to handle poles of up to 15 meters diameter. We did some initial calculations, and that installation vessel would cost about $800 million to build. We wouldn't be able to take that risk. So Ørsted would have to say, okay, we'll chip in, and we will guarantee you that in a certain amount of time, we will give you that work. You will make a return on investment. That hasn't happened yet, but it's a limit people are running into. These things tend to get bigger and bigger and bigger and bigger. To a point where you say, well, the investment you have to do to be able to install that is beyond proportion. And we're getting close to that point.
How much do you guys do your own in-house research on how to improve technologies versus
Oh, yeah.
like something like a ship and optimizing that? That's a little bit easier to like do some analysis and make contracts to bid out for the best possible things as opposed to doing your own research on TP and doing your own research on. I can think of thousands of things where you'd have your own research process.
Yeah, oh yeah, we have a research department, and we have what we call central fleet support. I don't know where that is, but let me click through a bit. Why isn't this going on anymore? Oh. This is what we do. This was an abandoned drilling vessel, the Jack Ryan. We bought that and we recycled it. It became the Boskalis 2. So we took an existing hull, got everything off, and then our own in-house engineering departments made that design. We put some extra parts here on the side, you can see here, for extra buoyancy. Put the crane on and designed all those tools ourselves. So a hell of a lot of research went in that. And we made from that vessel, which was dirt cheap because it was destined to be scrapped, we built a state-of-the-art wind farm installation vessel. Two main advantages. One, it's cheap because the hull is existing. You use a lot less steel, and steel at the moment is a premium. But the second is time to market. Because if you start from scratch and build a vessel like that, it takes 4 years. The conversion only took 2. So we have the vessel quicker available, and it is ecologically very friendly because you reuse stuff rather than build new. And we did the same with a heavy lift vessel, semi-submersible, and transferred it into a rock installation vessel. Same department, Central Fleet Support, did that. That we already owned that vessel. But if we see an opportunity to change the purpose, to repurpose a vessel, then we have the ability to do that. And not a hell of a lot of others have that. This makes us pretty unique. Okay, we talked about this. We talked a little bit about human excellence. It is about internal mobility, diversion and inclusion, using everybody that is available in the world because there is a shortage of capable people. And not just getting them in, but also keeping them, developing these people. It is about people. We invest a lot in we used to be on the stock market exchange. You could buy part of us. A Dutch investment fund, HAL, which is the Holland America line, which is not the cruise line, but the previous owner of the cruise line, and they sold the cruise line. They've been our majority shareholder for something like 30 years, and they decided to take us completely off the stock market. And they sanction our investments. We were planning to invest in 3 years, 1.25 billion. In 2 years, we were at 1.15, and we're going to spend another 600. And they fully agree. And the only thing they say is, do you need more money? It's a pretty good owner that has us, and they have plenty of money. They want to do something useful. Well, we talked about this. Little bit about good stewardship. It's corporate driven, responsibility lies with the board. But there's also things that are safety, carbon emissions, that's typically something the board decides on. But on projects, we are good stewardship. It means biodiversity, ecosystems, because that's a direct interaction with projects. Social and community impact. Emissions is an increasingly important topic. Touch on it just a little bit. You've probably heard about the scope 1, 2, and 3. Well, we can deal scope 1. This is direct emissions. Well, you can imagine there is at the moment no substitute for diesel engines. So 99% of our CO2 output is generated by the fuel of the vessels. But it's in our control. Scope 2 is our indirect emissions from purchased electricity, the offices, that sort of thing. That's also in our control. We have solar panels on every single building. We have 255 electrical car charging points at the parking facility. Scope 1, scope 3 is more difficult. It's your suppliers and it's your client usage. Now we can influence what we buy. Now, if we buy asphalt or steel, then we can influence that and try to minimize it as much as possible. Client uses it, it's a different thing. The environmentalists are trying to push us to say, well, you can do something about it. But if the Philippine government wants an airport, it's a bit difficult to say, okay, Boskalis, you're going to be responsible for all the CO2 emitted from the use of that airport. If we build a road, it's even more clear. If that road is used solely by electrical cars, there is no emission. But if it's driven by diesel owners, then it's different. So for now, we don't really have an answer to scope 3. We're trying to decarbonize the maritime industry, but we don't make diesel engines. There is no real alternative yet. We're investigating, but it's not there yet. And if there is an alternative like LNG, hydrogen, whatever, then that has to be available globally. So there's difficulties there, but we're working on it. It's basically 3 zones: zone of control, something we can do something about; zone of influence, where we can try to influence others to, and subsidize them in a certain way to make the cleaner choice. And then there's the zone of dependence, like we don't invent engines. We're looking into nuclear, but it's difficult. But it might be an option, especially for things we do that require immense amount of energy. So we're looking into that. Our carbon reduction ambitions, net zero 2050, depending on others as well. We have a parameter and we want to reduce our emission by 10% from 2030. That is our relative emission, because also we want to grow as a company. So it's not the absolute, it's an index. 5% has to come from operational efficiency, and 5% from using biofuels. And then we think we can do a reduction by 2030. So we are working on that, although people see us as the great polluter. We're doing whatever we can to stop that. And as you can see here, that net zero excludes value 3. If your business is building airfields, that's excluded. What we can do in the efficiency, that vessel that you see there in the middle, that's quite interesting. That had a bulb, and one of those bulbs is very economical, 1 speed only. We found out with a bit of research that our vessels never sail at 1 speed. And if you're at a different speed than what the bulb is designed for, you'll actually use more fuel. So we cut it off. So research is important in doing the right thing. We've got battery packs on our dive support vessels. Because if you use battery packs, the propulsion is diesel electric. If you're on DP, especially in high seas, we can now take 2 of the 4 diesels offline and run it through the battery because of the peak performances that the DP has to give. And that can be compensated by the battery. Saves a hell of a lot of fuel. We have electrification of onshore equipment because there it's easy. Simply run a cable. Preparing for the future, all-electric dredger. We have a building a dredger at the moment, big one, that can use methanol. We do have a hydrogen power. We are experimenting. Biodiversity, we're part of EcoShape, which is trying to, what we call building with nature. So if you're disturbing the soil, then make something out of it that is a better habitat than it was before. Trying to do that. And we succeed in mangroves, in placing artificial reefs, that sort of thing. Social and community work, talked about that. Now let's get into survey. This is the good part. Anything you just saw without a survey department is like this. You need to know where you are, when you are, how you are, in order to do that in any efficiency. And it's not easy. The world actually looks like that. Although most people think it's a sphere. So that's why we have a survey department to deal with that. And that's what my guys do. So what's important? Well, this is just a random picture, I think. But geodesy is important. Now we try to work with GNSS. Every country has its own system. So you have to transform it, and you have to check and double check and recheck again. Give you an idea. Every single British port has different data transformation parameters from ITRF 89 to OSGP. They're adjusted per port. It's not something that is national. So this is important. Geodesy is important. It's important to avoid that. If you can imagine that we're building a tunnel we talked about from Denmark to Germany, and you have the Denmark system, and you have the German system. They're not the same. And if you're not careful, this is what happens. So this is why you need survey. Geodesy is important. You need to check, you need to find the connection between the two parts, especially in construction, because this is a bad idea, unless you have a very big four-wheel drive and only go that way. And this happens. And this happens more often than you think. That's a nice anecdote. So this Fehmarnbelt tunnel is 18 kilometers long. And in the beginning, the client thought, well, let's split this scope in 3 parts. So we have a scope that makes the trench, and then we have a south contractor and a north contractor, and they're both going to build 9 kilometers of tunnel. They're going to meet in the middle with a 25 millimeter vertical accuracy. And just before they handed out those contracts, they decided, well, it might not be a good idea to try and have that connection 9 miles or 9 kilometers offshore, 40 meters down, and expect to be within the 25 millimeters. And we said, why don't you flex the 25 millimeter? Well, they couldn't, because the whole thing, the tunnel has roads but also a railroad. And the train with the electrical wires on top need that space. And if they were to relax the tolerances, they would have to build the tunnel higher. And the cost in additional concrete and rebar would be immense. They wouldn't be able to bear it. The project would go over budget immediately. So this is something you see a lot. They engineered all the tolerances to the absolute minimum and then say, here, contractor, you can fix this. Because this is the cheapest way to do it. And the same happens when you dredge an access channel to a port. 30 years ago, single beam times, tight gauge times, everyone would add a safety margin. So there would be a safety margin on a safety margin on a safety margin to get your kill clearance. But that's costly because you're digging stuff that you shouldn't have to dig. So under economic pressure, people found ways, if you work more accurately, you can reduce the safety margins. So where you had a safety margin of 4, 5, 6 feet years ago, it's now 1 foot because of the increase in accuracy of positioning of water levels and that sort of thing. So all the safety margins have been taken out in order to keep these things economically viable. That's why you need a survey department. That's what we deal with every day. Very high accuracies. And not a lot of people realize this. You lot will. There is a difference between land and water, although in these two pictures it sort of seems the same. But that's static. That's fully dynamic. So if you stop all your activity there, nothing changes. If you stop all your activity there, everything keeps moving and changes. Then again, that water level isn't static, is it? You have something called tide. So it moves all the ways. It's weather dependent, it's dependent on the moon, it's dependent on anything. It's dynamic. Even the sea floor is dynamic. The thing we're trying to measure is dynamic. Because if you're in lots of areas, you get ripples. And those ripples migrate. Sorry for the Dutch in this sheet. I stole it from Rijkswaterstaat. These ripples, they move over time. So your sea floor is also dynamic. And accuracy matters. This is a satellite image of Manila Airport that will be built, hopefully you can't see that. From there to here, this side will be Manila Airport, which is big. And we need to bring in sand to reclaim that. So the area is 17.5 million square meters. 20 million square yards. The contract volume is 100 million cubic meters of sand that we have to bring. And we calculate everything in cubic meters of sand. Because we know the wear and tear of a cubic meter of sand. We know how much fuel we need to spend. We know how many cubic meters of sand per hour we can produce. 1 centimeter difference, vertical difference, over that area equals to 175,000 that's supposed to be 3 cubic meters at 10 $10 cubic meter. It's not cubic meter. Anyway, a centimeter is 1.7 million in cost. How accurate can you measure with your GPS backpack? Plus or minus 3? That'll even out a bit. But if we're 5 centimeters off, that's a lot of money. So accuracy matters. And repeatability matters even more. If you do a survey with one vessel and you do the next survey with a different vessel, there is going to be a difference. And it might be in your advantage, but it might also go the other way. So accuracy to us as reclaimers of land is money. And repeatability is more important than absolute accuracy. But absolute accuracy, see the bridge, is even equally important. But what is also important is the reference plane. Installing a monopile requirement. This is not something I made up. Install the flange height 10.5 meters above LAT with a tolerance of plus or minus 10 centimeters. Now that's fun, huh? The question is, how accurate do we know LAT somewhere offshore? Do you know how long it takes to determine LAT somewhere offshore doing measurements? 19 years. So if nobody had put a dive gauge there for 19 years, that is a ridiculous demand because the reference isn't there. And that demand, of course, comes from people who originate from that static environment, because that's where the electricity companies start. They haven't got a clue. And that's why we, as hydrographers, ocean scientists, ocean engineers, are so important. Because we understand that dynamic. And that dynamic tells us that this is bullshit. There is no other word for it. We'll sign the contract and we'll build it, but it's ridiculous. So, choose your reference. The sea surface as a water level is not a good reference because it moves. The relationship between positioning and reference level shall be mathematically defined and exact so that you can calculate one datum to another. There's lots of issues on lots of projects where those transformations and the mathematical relations are not clear, simply because the local government doesn't know. Multiple measurements over time shall be comparable. The reference level shall be fixed in time, at least for the duration of the project. That's not the case everywhere either. But then, the seafloor itself was often used in oil and gas as a reference level. And if you're in deep water, who cares? Everything relative. In deeper water, and be below 50, 60 meters, you hardly see any moving sea bottom by ripples or that sort of thing. That's all dampened out. So you could use that. But as we go away from fossil fuel and into in this energy transition, we tend to install monopiles, jackets fixed to the seafloor. So you come shallower, and that seafloor usually is moving. So you can't use the seafloor anymore. It's a problem with, a major problem here is depth of burial of cables. Because they want it at a certain depth, they want it in a certain layer because of the heat emitted from the cable. And if it's in the wrong layer, the cable may overheat. But related to what? Reference levels are very important to assess what you're doing and to get it done right. The bottom may not be stable over a relatively short time. All in all, difficult. Well, what do we provide as a department? We provide knowledge through an operations desk. We provide personnel. I have 200 surveyors working for me worldwide. And we provide survey equipment to support the projects. Operations desk, operations managers, HR managers to deal with people, support for pre-qualification. Very important. Tendering, what method are we going to use, which is going to cost. Execution, methods, procedures, quality. Knowledge management, I've seen it here somewhere else. You know, they said map once, use multiple times. We have learn on one job, apply everywhere. Personnel, about 195 surveyors worldwide in the international pool, plus 33 in the Netherlands market, plus 7 in the UK market, plus 12 office staff. 100% international projects, 70% non-Dutch. This was very different 20 years ago. All sorts of nationalities from anywhere. That's a good picture. That's in Sweden. That project was run by, with the first project, all female survey team. No guys. That was a first. There's not a lot of women working in the marine construction industry. So this was something we were very proud of. Some equipment. See your basement. This is my basement. It's not a basement, it's 2 floors of a large production hall. And those are mainly empty boxes, thank God, because the equipment that's supposed to be in the boxes is out there in the field. We've got about 60 million euros invested in survey equipment, just for internal use. What do we do? Bathymetry. This is our bread and butter. We've got one of those. We showed me one of those. We have one. This is what we do mostly, especially for dredging, because measuring where the bottom is. As I said earlier, once a day, twice a day. Very short turnaround. Keep them fed with accurate information so that they can work efficiently. Mapping is also what we do. This is a picture up there of a bauxite mine in Suriname. We had to dig the overburden off. And that needs to be mapped every day. We need to map roads if we build roads. We do mapping. We do laser scanners on cars. We use drones. There's an incredible amount of difficulty legislation-wise. Service positioning. This is what I talked about when I said we were doing a float over. That's a platform structure. And you can see it's got ends of tubes. There. And it needs to be put on piles offshore. And that's a camera view of the stubbing cones. And this is our in-house developed software that shows you 1, 2, 3, 4 bullseyes. And we monitor continuously where this vessel is going with the top side on. Then when it's lowered, we suddenly have to monitor 2 positions. That's what we do, service positioning, very accurately. Doesn't have to be absolutely accurate, but relatively, it has to be very accurate, because we don't want to have the barge, the vessel that brings in the load, touch the pre-installed cones. Subsea positioning, we do. That's a picture down there of a trencher that's burying a cable. Obviously USBL stuff, positioning, ROVs. Environmental monitoring. Mobile monitoring, detecting sediment plumes around where we work. We deploy buoys to make sure that certain levels are not passed, so that if we're working close to a coral reef or something, that we don't completely make the water turbid and then the coral reef die off. We've developed those buoys. Collect mid ocean data for our workability, because there's a limit to when a vessel can work. So we'll do that. We'll deploy the buoys, operate them. Underwater imaging, this is big fun. That's an X-block, which is used in putting an armor layer on a breakwater. And X-blocks have to lock into each other when you put them on the breakwater. We use a Octopus echoscope. That's the picture on the right, where you see the X-block. You can interlock it with another one. That's sort of a mixed reality, because as soon as the software recognizes it's looking at the X-block, it'll map the actual design of the X-block on it, so that we can actually accurately do that. The picture below is also fun. That's done with an Avis type acoustic camera. That's a car tire with a piece of proton. Incredible resolution, fully acoustic. This is used mainly in, well, not this one, there's another picture. I'll get to that later, where we use the Avis. Side-scan sonar imaging we do occasionally, not very often. Did you see there the drag marks, especially this? This is the leg of a jacket brick. That needed to be removed. The jacket brick obviously fell. We had to get the jacket brick out. That's when we occasionally use side scans. Don't use a lot. Some sub-bottom exploration. This is mainly for salvage, where we need to find if they cleaned an area, whether all the metal has been taken out. So we'll do that. Occasionally we'll look into the sub-bottom. We have some sub-bottom simulations, but it's not very often. That one is, the picture on the right is on our vessel Camara, and that does UXO clearing. That's where we use the irises, so that we can, we use magnetometers to locate UXO, then bring in the ROV, then with the camera we blow as much sediment away as we can and try to identify what it is. And once we know what it is, we will know how to, whether it is UXO or not. And the next step is how to dismantle it. European waters are riddled with ammunition dumps from World War II, but also lots of unexploded torpedoes are lying around, especially in the Baltics. And we have a daughter company that clears that. This is the substation, the neighborhood substation I was talking about. So that gets put on the seafloor, and we need to lay the foundation for that, but we also do the transport. That's slightly bigger than the one you'll find in your local neighborhood. It distributes the power. This is the last slide. Questions? Yeah.
A few questions. I saw on the one of the first slides about the map that you had from the offices and everything. I saw that you guys have an office in Panama, but no projects or operations there. Is that just to have like a strategic location?
The office in Panama holds the regional manager, and it only holds the regional manager. The regional manager job is to continuously follow the local news, the local developments, to see whether an opportunity comes up where we can have a bid. Keep the relationships going with our existing clients and possible clients in order to be able to act when something happens there. Because it's not like we get emails from around the world saying, could you please, sometimes we do, but not in most cases, could you please put a quotation in for the development of an airport locally. So you have to be on top of that. So a number of those offices are very, very, very limited. There will be a regional person, a commercial person.
Well, quickly, just for Sjoerd, just tell what countries you're from.
From Tunisia,
Tunisia,
Jamaica,
Jamaica, Panama,
Greece.
Greece,
United States.
France,
United States.
Algeria.
Nigeria, students,
United States.
Brazil.
Brazil, Colombia,
Portugal.
Portugal. Any other students we left out? So it's quite an international line.
Yeah, you're
Oh, I can see. You got a black.
Oh, wow.
Oman. So we have quite an international group here.
Actually, I've only not been to Panama.
But he hasn't. He hasn't.
No, and, personally, I haven't been to Panama, but I've been to all the other countries.
And you have
Very
worked,
international.
you have worked in all those countries.
Yeah.
Yeah, so take the card.
Yeah, I'm not here on a recruitment.
No, but we did talk about there's a great need.
But
there's a great need.
there may be possibilities, depending on our order intake over the coming year. At the moment, we are very, very busy, but we see a slump coming by 2025. So I'm not actively recruiting at the moment. That doesn't necessarily mean that people are leaving, so we'll always, but there's no formal recruiting drive going on at the moment.
But these aren't your regular people.
Yeah.
These are special ones.
Fully appreciate that, Larry. It's why I'm here. It's why I fly out.
So, Ahima, go.
I just wanted to ask you about you said that you are not recruiting, but the possibility for internship for us, the irregular people.
I had a discussion with Selma yesterday. Internship, yes, if I can accommodate it. I can't guarantee that. The thing is, if our activities go down a bit, then obviously the amount of internship places also has to go down. At the moment, we're very busy, so we hardly have capacity available of experienced guys to help you with your internship, because an internship will be on a project and not be in our office. When the order book decreases, when it increases, everybody's welcome. Because we struggle to get hands. So you'd be on a project before you knew it, and after 2 days of watching somebody else, you go do it, go fix. But if it's declining, then they'll try to minimize the cost on projects, because they don't know what's coming next. We're looking into standbys. So they will not be taking off. And there will be plenty of internal experienced people to help. So then the project managers don't want any trainees or interns around, because simply your production is less. And it's not the idea that an intern should be part of the full production process. It's something you grow into during the internship. But it's the way they look at it. So we always have difficulty in a slightly declining order book and declining market for us to place as many interns as we want, because we think it's very important to have many internships. But then again, there's more universities than this one, so there's also a bit of a competition going on.
Okay.
But if you're interested, let me know, and then we'll see what we can do. But there is no guarantees. It's going to be, especially from this fall onwards, it's going to be difficult to get internship placements. Also, internship placements tend to work better on the dredging side than the offshore side, simply because you have to have a shitload of license to operate trainings in order to be able to go on a vessel, even enter the port in some cases. So in dredging, we don't know that. It's just, what do you need? A ticket.
So yesterday we had that interesting conversation about the lack of sand, proper sand.
Yeah.
And I'm just wondering, how does Boskalis
We're out of sand. The world is out of sand. It's strange, but we are. Sand that can be used for construction, with that you can build on.
That's a really interesting thing, and I suspect most of you don't know this, but Larry Ward here has been working for years basically on projects from the BOEM, Bureau of Ocean Energy Management, to map sand resources much further offshore than typical. And then it's recognizing this shortage of sand, which is probably the second most valuable natural resource after oil and gas.
And water, fresh water.
And fresh water, yeah.
But sand is,
And so there's a huge project, go talk to Larry about it, he's teaching you right now, right? So ask him about the sand resource project he's doing offshore here.
and you can't use land-based sand, because land-based sand typically has rounded off edges. If you try to make cement out of land-based sand, you'll be amazed. It won't hold anything if you build a brick house. You need sharp sand. That's what we call it in Dutch. It has sharp edges. It comes from the sea. And it shouldn't be too old, because it's too old, the edges will have rounded off. And you need that sand mixed with cement to have something that has holding power. And the same goes for if you want to build on it. If you use, it's like when you walk onto the beach, the first few steps that have been dried in the sun, that's rounded sand, and your feet will go down. There's nothing holding it together. Whereas when you come to the waterline, that sand is typically more sharp, and you can easily stand on it, and your feet won't go deep into it. Yeah.
This was part of actually my second question. You guys do sand extraction as well, besides dredging, or no?
Sometimes, but not on
For
all.
construction?
But yeah,
How do you deal with, for example, coastal areas getting erosion due to the sand extraction?
but you shouldn't do sand extraction close to a coastal area. You should do it away.
Okay, well, my question is.
We mainly do replenishment in that area.
Okay, because in Panama, there's a huge issue regarding that. They do a lot of sand extraction offshore, and most of the coast in the Pacific side is eroding and eroding and eroding without anybody like supervising that. I was wondering how people deal with that.
There's people don't deal with it, governments do. And typically we're doing a project in Togo and Benin in Africa at the moment, where we're building on a coast that is eroding quickly. We're building breakwaters into it, so that the sand doesn't flow away anymore, but is being kept where it is. And then on top of that, we'll do a replenishment on the one side. So there's always one dominant current that follows the shoreline, so the sand will move into one direction. So we'll dump a load of sand just before the area that's hit, so that we feed the stream with sand that we have artificially put there, in order to maintain the coastline as much as possible. They've done that in multiple locations. So there is remedies, but they cost money. We're not
So the answer is hire Boskalis, then you have a big office in Panama, and they'll maintain the.
yeah.
We do need somebody to maintain the coast because it's a disaster.
I mean, if you can get a coastal engineering firm to make a plan like that, and we'll come and execute it. If you can raise the funds, which may be a problem.
Okay.
One more question. So if you install export cables or an inter-array cable at a wind farm project, I'm guessing you guys also do the surveying post-installation, like during operation and maintenance, is that true?
No.
No, okay, so that would be a separate survey company?
When we deliver, we want out. So we'll build something, we'll put it there,
Job's done.
and job is done, and then we're gone. Guardline, our survey company, might want to do the annual surveys, but the contractor part where I work, finished out. We don't want to do maintenance surveys or that sort of thing. That's our business line.
Okay, but if the cable needs maintenance, then do you come back or is
Oh,
that, okay?
Oh, yeah, in quite a lot of cases.
Okay, and then once you install a cable, do you provide a recommended time frame for how often it should be
Nope.
surveyed?
Nope, that's up to the operator and our client to say
Okay.
that.
Because I used to work for an offshore wind farm and developer, and they used to always say, oh, it's up to the cable manufacturer and the cable.
Mainly, it's a combination of things. It's the cable manufacturer says one thing, then it's the operator that has the license to operate in the geographical area that has to figure out what the local components are. If there's, if it's very shallow and a lot of storms and there's a lot of sediment movement, then you might want to survey more often than when it's at 60 meters of water depth in a pond that has no flow. So it's a combination of what the cable manufacturer says, for the stress it can hold, that sort of thing, and the local environment, and usually in a government license to operate something like that, there is a clause that says how often you have to survey it. So there's also government regulations. So it's a combination of things that determine how often that needs to be done. And then typically an operator will hire a survey company to do that survey. And that's an easy survey because it, usually you have a year to do it. You could even do it with an ASV. Whereas you can understand that this is all time critical. We don't use very many ASVs. Because this has to be done when it has to be done. You can't postpone it a month. There's a 200 million euro-dollar vessel waiting idle for you to finish the survey. That's not a pleasant feeling.
On that happy note. Thanks, Sjoerd, again.